I'm a contractor for Northrop Grumman, and I work for the Bureau of Land Management, which is a land management agency of the U.S. government. This is the abstract of the presentation, which is a lot of words, and it's the last presentation, so no one wants to read that. I know. So the BLM is our short term for Bureau of Land Management, and it is a Western land management agency. It covers a lot of the Western states. There's 245 million acres, more or less, that they are in charge of. They can keep track and provide services for people grazing cattle, extracting oil and gas, extracting minerals, water. And so we have a lot of data sets spread across a lot of states, and we are trying to create national compilations of these data sets to provide out for research as well as for public use. We're working on the public part. So my position is working to create these compilations, and so what we did was we were trying to use the change detection transformer to help in the process of creating the compilation. So this is a brief summary of how it works, which is just more what we're going to be covering in each slide. Basically, each state has a replica that we collect the data from. And so we have a copy of each state's data, and then we process it all through a compilation. So for our feature change detection, we have three inputs: the original feature class, which is the default table, an updated feature class, and then the total compilation. And then the output is the changed features, or the added features, the unchanged features, and the features that had been deleted. Since we're using an SDE, we're managing the change detection with a version. And this is what the inside of the feature change detector looks like. We'll step through each of these pieces individually. So the original change detector, because it's a version database, when we have the replica synchronized, it changes the default version. Our updates version that we have as well is the, sorry, explaining this gets complicated. So when you create the replica and when you synchronize the replica, the default's changed, but the version isn't changed. And then you can compare the default table and the version table and see the features that were changed. Now, in SDE, it's fortunate that when you update or you edit a feature, it actually deletes the old feature and includes it as an added feature. And so you can see the differences between those tables as data is being edited at the local level, and then you can get out just the features that had been changed. So when we compare the default and that version, anything that's been unchanged we don't care about because that's not part of our compilation. We only need to address the things that have been changed. And so then we have the added features. And so the added features are, we have to copy the global ID from that feature onto our compilation. Since we have this large compilation of the US and each state providing their own data, when they delete something on their side or when they change something that causes a deletion in the tables, then we need to delete it from our compilation table. And the only connection we have from the local table to the compilation is the global ID, so we have to copy that over to the compilation. And that's our original global ID attribute that we add to it. So then, like we were saying, the deleted features, we use that global ID to connect up with the compilation and then flag it for deletion when it's sent to the writer, which really becomes kind of an unwriter and deletes the feature. And so in the output goes to the writer, and we take the added features, which is everything that's been edited, and the deleted features are anything that's been deleted or removed or updated. So that's the basics of it. The first step that we do have to do for the initialization is if you have no changes in the data that you're providing, but you need to populate your compilation with all your original global IDs, you have to direct everything from the unchanged feature down into the global ID copier into your compilation. But you only have to do it for the initialization process. So when I wrote this abstract 6 months ago for my original approval of the approval, this is how we were doing it. In that time, it got frustrating because if something would, we had a couple hang-ups that would happen. Some of the states kept taking down and updating and changing their replicas. And every time they changed their replica, you'd have to go in and manually extract that state from the compilation and then re-add it in because they had reset all of their global IDs. And so anytime that happens, it throws off the entire synchronization process. The other issue was in our processing of FME, we were getting geometry errors that would force the workbench to quit halfway through. So half the state's been processed and worked fine, but then the other half hadn't. And so you had to kind of go through and figure out which states still needed to be run and which ones had been run. If you run it again just straight, you'll have a lot of duplicates go through again, and that gets frustrating. What was the other one? Oh, and one of the reasons we originally did this was there was an initial requirement to have track changes turned on our compilation database so you could review the changes as they were being made through time in the database. And that's why we had to make sure we knew which features were being changed when. And they removed that restraint or requirement from us, and that made it less enticing to try to keep this up to date. Oh yeah, we have one office that doesn't use replication, or they don't have a server set up. And if the version is also posted, if the version you're using to see the changes between your default and the version gets either reconciled or posted, depending on how you set it up, you can't go back and find which features have been changed. Once those are the same, tracking or the change detection doesn't work. And it was hard to say for sure if we had all of our features in our compilation because there wasn't a great way for us to go back and find it without doing a lot of manual matching work. But since being here, one of the issues we're having now is we started going through the process and creating just deleting all the old features and creating a new feature class of the compilation. But the issue with that is it was now taking us for 4 feature classes, it can take 20, 30, 40 hours to compile it. And there's a lot of steps that go along with that, but a large part of it is if you have a data set of a couple 100,000 records, deleting that whole thing and then rebuilding it with all new data. So I'm probably going to come back to this and try to improve it and improve the workbenches to actually use this and only have to process, the 20 changes from the week. And that would speed up the time it takes to make these compilations. So it's still kind of a work in progress. And technically it works. It takes everyone else working with it and understanding what it's going to need to do the work. I kind of feel like I rushed through that, so if you have any questions about how it works, feel free to ask, and we can just go backwards as well. And that's about it. That's my contact information. And yes, thank you. Yeah.
Which transformer are you using to build the global ID?
Copy attribute.
Also, that's an internal, you're not using FME to build the global ID.
Oh, no, to build the global ID, it's the Esri. The SDE requires you to have a global ID field for every feature class.
So that's not the object ID though, right?
It's a global ID. It's a like 32 hexadecimal character long unique ID that Esri generates.
If you built, this is hypothetical, but if you build an ID using the CRC calculator, for example, then that ID would change when the feature or the feature attribute combination changed, but it wouldn't change in the future if the feature or feature attributes have been touched. So, I think the Esri global ID is kind of, it's dynamic. It just changes for the sake of it. Well,
it changes anytime you edit the data, which is because every time you edit the data, it deletes the original version and adds the new version as an addition.
Yeah, but just the act of creating a version touches the global ID, doesn't it?
No.
Okay.
No, because creating the version is creating a new set of tables, and it writes down global IDs, but it's only when if you start editing on a data set, like if you double click and get the vertexes to show up, then it starts thinking you did something to it, and it will put a delete and add in the tables and change the global ID. So one of our issues that we're working through is that we have all these states, and they're all doing it their own way. And one of the reasons it takes so long to process is that each state has a different idea of what their attribute collections are and their standards and how they're managing their data. And so we're using FME to process and push it through and to come out one unified data set. And we got them all to use Esri, so we're pretty happy that they're all doing that.
I think the suggestion there was you might use the CRC calculator to calculate the CRC code for all the fields that would comply with your compiled database, and then you can look for changes in that.
Oh, okay.
Yes. So I don't know, did you all hear that? But the option is to use the CRC calculator using all the attributes and the geometry to create that unique ID, and then you can just compare the changes in this.
It's a lot cleaner because you don't have to worry about synchronizing global IDs because you're talking about that initialization process and how all your IDs could get out of sync if one of your external providers, you know.
Maybe I need to talk to you more after this.
Well, the issue I think he has is that the external providers you can't go changing their data structure. So the only thing they've got is global IDs in there, because that's what Esri provides. And so then you're trying to pull that data together and figure out how to figure out what's different.
Right.
Yeah. So the replica, is that using Esri's replication
Yes.
process?
Yeah, so we have it all kind of wrapped up in Python to call each piece, and half of it's Esri pieces and half of it's FME pieces, and they run in order and push everything out.
Yeah. Anyone else? Yep.
So you have several different offices that submit data to your program, is that correct?
Mhm.
Is that how that works? So are they all using the same format, or how are you getting around that issue?
Yes, we have standards, but that doesn't mean they all use the same idea of the standards. What we do is, my coworker in the back, Burke, gave a presentation of this earlier in the week. We have standards that we check for, and we run all the data through these checks that say, does the attribute exist, and do they meet the values that are defined in the domains? And if they don't, then we have a process that sends an email back to them saying, these are all the problems with what you did. Ideally, they would make them want to change those errors, but it doesn't always. Depends on who their boss is.
So then how do you, I guess, reconcile that if the people in the field aren't changing their mistakes or their...
We're working on having a data committee with more power, but that's still a work in progress to get that to be identified as an issue that needs to be corrected. And we're working to do that through emails, through creating services that show where the errors exist, and trying to explain what's wrong with the data to as many supervisors as possible. Because usually once we get the director of the office aware of the issues and what it would take to change them, they're very encouraged to lean on their staff to get that to happen. But it being government work and budgets, sometimes the time isn't there to get it done.
There's another question over here. Yep.
So are you able to use the same workspaces for each state, or do you have to group them depending on what their data sets are?
No, we have a standardized workspace for all the states.
Oh, okay.
And so each feature class has its own workspace. And we try to push it all into there as much as possible. And so our other issue was that each state has their own local projections, and we need to put it in a national projection. So there's that step that it goes through as well.
About how long does it take to process the state's data?
It depends on the data set. I mean, some of the, like our grazing allotments is one of our larger ones, and just the space, acreage it covers, as well as just the number of features, that one runs for 30 hours. And that's just all pushing and pulling things together. Yeah, so cutting that down by only having to do the 25 changes from the week would really make that go faster.
Yeah.
So, I mean, like, was it for that grazing one, reading in all the features takes half an hour just for the workbench to read it in. Is it 15 minutes or half an hour? It's a timely thing just to watch it go through the reading process, and then it blows up and it fails on something. It's frustrating.
Yeah, although it's interesting that you said it takes that long to read it, because I'm going to put on my training hat here. But basically, when we read features from a source, we take that feature as far as we can through the workspace before we go back and read the next feature. And so that feature actually is traveling through to what we call a blocking transformer, so a sorter or a aggregator or something that's going to join features together. And so it's very interesting. If you think you're having performance issues with the reader, is to take that workspace and go read to FFS, and that's all. And then when it goes like that, you will realize that the problem isn't with the reader, it's with something further down through the workspace. And so it's I don't know if you've ever tried it, but
No, I haven't, but I can imagine this.
it's really worth doing on a workspace where you feel that it's the reader that's the problem, because it gives you a benchmark. Then you know that's how long it took to get the data into the workspace.
Oh yeah, I don't think the reader's the problem. I just
No,
think
but you know, I know
I'm
what
sure
you
there's
mean.
one of those
Yeah,
things in there
yeah.
that's saying, all right, stop here until you get everything, and it just is
exactly.
telling me it's reading stuff.
That's right, because that's all it shows in the log file, is that
Yeah.
it shows that we're still reading stuff. So that's good. Interesting. Yeah. Anyone else? No. Okay. Well, thanks very much.
Enjoy it.